Hi everyone. We'll start at the top of the hour. Thank you for coming. In the meantime, I'm adding the paper right now. So if you want to have a look at it, there we go. Hi Lavina. Hey Mike. Hey Abraham. Hi Bio. Thanks for coming. We'll start at the top of the hour. Hi Ben. If you want to come up and participate in the discussion, feel free to come up. I think it will be interesting. Uh, Hi Ben. How are you?
Hey,
Relative
Katrina. Yeah,
indicators.
it sounds fascinating. I've got a call in 6 minutes, brief call, but I should be able to hang around before and after that. So.
Oh, great. Yeah, I think today is kind of a more intuitive topic, so I think it's good for participating today. So everyone feel free to join the stage, and our guest speakers should be here in a couple of minutes. So thank you. Hi, Lavina. I haven't talked with you in forever. How are you?
Yeah, I know. I'm doing well. How are you?
Good, good too. Yep. I think
Oh, excellent.
our schedules don't overlap too much, probably. I don't know.
I think it's just been a bit crazy. I've been traveling quite a lot and attending a few conferences and speaking at them. So I think it's been more on my side. But I think things are going to quieten down a lot now. I love today's topic. I mean, it reminds me somewhat of, a bit on collective intelligence. So really intrigued.
Yeah, I love this topic too. And there was a data about it when people are in the same room. But I don't want to give too much away for a guest speaker. So but yeah, exactly. But I agree. Hi, Mitch. Um, Hi, Westlix. Everyone that wants to join the discussion. I think today, I mean, I always welcome everyone to participate. I think it's just more interesting, and everyone has different types of questions, so it makes it way more interesting. But especially today, I think it's relative intuitive research. So yeah, please join us. Hi, Frank. Do you want to come up? I think today's room will be interesting, also from the research related to the research you do. So, welcome, everyone.
So I'm going to dive off for this call, Katrina, but I'll pop back later on. The topic looks really fascinating, though. As a keen gamer and somebody with an interest in science, I'm quite interested in the topic, so I'll see if I can come back
Okay,
later.
perfect. Yeah, usually we take a little bit of introduction and a little bit of interview. So until we get to the research, it takes around 10-15 minutes. So you shouldn't miss too much, maybe. Okay. Hey everyone, we'll start any minute. Our guest speaker should be here any minute, so thanks for coming. And in the meantime, you can check out the paper that's pinned on top of the room. How? Hi. Hey, Vatse. I hope I'm saying your name right. I don't know. So do you know how to unmute? It's all the way on the bottom right. There's the microphone symbol. If you, yep, perfect. How
Right,
are
I
you?
found. Yeah, I'm all right. Just the moment I need to figure out my headphones. They are somehow not connected.
Oh, but right now your voice sounds great. So okay. So welcome everyone to the Science Society, and of course a special welcome to you, Vatse. And again, I hope I'm saying your name right. And let me give a brief introduction. Valtteri Wikström, he is a doctoral researcher in the Department of Education and Cognitive Brain in the Cognitive Brain Research Unit, and he's in the doctoral program Brain and Mind at the University of Helsinki. And today he will talk about the paper that's on top with the title Interbrain Synchronization Occurs Without Physical Co-Presence During Cooperative Online Gaming. And welcome to our club, and thank you so much for coming here today.
Thanks for inviting me, Katarina. It's great to be here.
And before we
So,
start, we usually ask like a few interview questions, if that's okay with you. So how come that you picked like the field of science? Was it something you always wanted to do, or was there some specific that you wanted to, like a book or some teacher or professor that kind of elicited the interest in doing science?
that's a great question. Yeah, I have to think. Well, at least I mean, it was not something I was always thinking to do to do science, but I think I kind of ended up doing it through uh, some research assistant work. So just during my undergrad, I ended up at the lab, and actually, then person who is now my supervisor was the person who was running that lab. So I guess I just found a nice group of people who I like to work with, and that's how I ended up doing science.
Well, great. So, and your research is about people and how they work together. So that's quite interesting. And how did this project come about? Was this something that you were kind of curious about, or was this like ongoing research, or did people like think that it was something you should do, or did people think you're crazy? It happens. So, is there like a back story about this specific project, maybe?
Yeah, so the lab that I joined back then for as a research assistant is like a music and neuroscience lab. So it's not really exactly the topic that I ended up then continuing with. So what actually happened was that I had some colleagues from that lab, and after a while I had already stopped being a research assistant there, but they knew that I was into this kind of things like interactive media and emotions and stuff like that. So we applied for a competition, like basically like there was a bigger group of people, but just me and then a PhD student. I wasn't a PhD student even at the time, and we got then funding for ourselves, which was quite rare, I would say, in that way, that we could start with our own idea. So that's how we, like, out of interest, but without a professor at the time, like uh, who would be an expert on this field.
Oh, that's great. And that's great that you actually had funding for this. I know we do sometimes projects without any funding. So, congratulations and to this great publication that I think got some interest. So, that's really great that this came out of it. So, yeah. And yeah, so the stage is yours to like give everyone like overview over your research. If you want to also talk about related projects, feel free to do so. And yeah, the stage is yours. Thank you.
Great. Just before I start, I would like to ask that the audience here, I suppose, is very from different disciplines. So I should maybe start with short introduction,
Yes,
or
yeah,
what do you
yeah.
think?
I think that would be good. Thank you.
Yeah. All right. So, hi everyone. So today I'm going to present this paper that has been linked on the top. This interbrain synchronization occurs without physical co-presence during cooperative online gaming. And to start with, I guess I should maybe introduce some concepts, like especially related to this interbrain synchronization. So there's a phenomenon that has been found here, like in the last, I would say, well, in the last 20 years at least, maybe, and the research has been increasing all the time. Now you find quite many papers published this year, which deal with the topic of interbrain synchronization, and it's like a phenomenon that sees that the brains of people tend to end up in a similar state when people are interacting together, and this is of course a very wide concept. Like similarity in brain states is can mean various things, and interaction can mean various things, but certain kind of general aspects have been found that seem to repeat from study to study, at least quite often. So first of all, like it seems that people who are closer together, they seem to synchronize more, and then also people who cooperate tend to synchronize more than people who compete in a similar task. But then again, those kind of things seem to depend also on the task itself. So in a certain situation, it might not be like that. And it has been linked then with pro-sociality, so kind of empathy-related features. So when people are experiencing more empathy, or when they are more empathetic, they would then have more of this synchronization. And on the other hand, with cooperation in the form of like cooperative performance, then seems to be like this. If you're working together on a task, then there will be synchronization occurring. This is my dog. Sorry, Lucky. Yeah, and so what we wanted to study with our the paper, or what the study that our paper is presenting is about whether or not this type of synchronization requires physical presence, because mostly the research has been done with people interacting face to face, and at the very least then in the same space together. So then there's of course aspects in the space and like noises and movements and gestures and so on, which can be seen and then could be a cause for this. So we wanted to see if we can recognize some of this synchronization to occur also online when people are interacting only via computer, and then not just that, but if we can link it then to cooperation in that situation. So from this starting point, we needed to design an experiment where it's possible to measure the cooperation, and that's kind of the approach that we decided to take. So we wanted to create a task where we could see, like, okay, if people are cooperating better, if their cooperation ends with better results, does it then reflect in this synchronization, and in which way? And it was not so simple to figure out a task for this, because first of all, we didn't want to have some audio or video, like we didn't want to replicate the face-to-face situation in online interaction. Rather, we wanted to have something that happens in a way purely computer mediated, somewhat abstract, so that there would be a kind of very controlled environment where we know all the things that are happening, we know the interaction. And we were thinking of all kinds of different games and tasks that could work like this, and could then be like good at producing some feedback that would be required for this kind of synchronization to occur. And what we then started or got most inspired about was maybe this kind of mirror game type task. So the mirror game is like a paradigm that was developed for studying social cognition, and especially like this kind of joint movement where people are moving like a slider or something else, but the task is to follow the same pattern together, but there's not like a clear pattern, like mirroring each other basically. And we started with this idea, but then we kind of quickly realized that to measure then this interbrain synchronization during such a mirroring task would be like quite difficult, because we would have a hard time controlling for the artifacts that could come from muscle movement. So brain imaging methods, and especially EEG, which we wanted to use here, because EEG is like a lightweight method which can be used quite easily in like relatively normal situations, compared to like then other methods which might require like a whole room, or like an MRI tube where you put the person inside. So we wanted to have something lightweight, and also we had experience with EEG. But in any case, the EEG method especially is quite vulnerable to noise caused by muscle activity. So if you would have a task which requires people to mirror each other and synchronize their movement, then it would be very likely that we would also get then kind of even more muscle information in our data than information coming from the brain itself. So this thinking led us to then try to figure out a task in which the people who are performing it, the pair who is performing the task, would have like a need to not do the same thing at the same time. And this how we then ended up with a game where people are steering or driving a car together, and the other person is steering the car and the other is accelerating. To some extent, this was inspired also by an episode of the TV show Top Gear, where they actually built these kind of cars, but with like they welded together two cars, and one person was sitting on the top car. It's quite funny to watch if you want to check it out. You can find it on YouTube if you look for double-decker cars. But yeah, so we created this kind of game then, in which it's just shown from like top, like from bird eye view, and then there's a car driving around racetracks, and then one person then has to steer the car and the other brakes and accelerates it. And this task was also good in another way, because I was very interested to, or I've been very interested in general to use physiological data also for real-time use, like interactive use. So I was kind of curious to measure also this interbrain synchronization, not just like over like a whole period, over a whole experiment, and then based on the performance during that experiment make some analysis, but also to analyze as granular data as possible. So with this task we could actually divide the track. So I in case you have the paper open, you can look at the first figure 1, and there you can see one of the tracks, and on the next to it you can see the same track, but in like how it was represented for the computer. So what we did is we took the track and we divided it to quite short segments, and then labeled them with like a specific trigger value. And in this way we could send triggers which are like these kind of markings for the EEG recording device, and those markings tell the device usually what stimulus is presented at what time, but in our case it would then tell where in the track exactly and on which track the team was located. So with this we were able to create also like a granular measure, so not just like measuring lap times or measuring how many laps the team performed during the task, but rather we could see how fast they were in between each track segment. And how we then used that was that we because of the way we were analyzing the interbrain synchrony, we needed around 3 seconds of data to make a like to create a value for the interbrain synchrony. So we cut our data into 3-second segments, and then we could see that during those 3 seconds segment, or during one 3-second segment, from which which track segment did they start from and which did they end up in, and how long was the time between those segments, and then by comparing that time to the performance of the like all the other pairs, then we could give a score for then each 3-second segment on the track. And in this way we could then analyze also the momentary performance and and momentary synchronization. Yeah, so that was the task, and then I guess I will tell about the analysis and results of that. But in case someone has now any comment or question about the setup, the task itself, then I'd be happy to hear it here at this point.
Yeah. So they were not able to like text or message or in any other way, right? The only communication was playing the game, right? That was the only way to communicate, basically.
Yeah, exactly. So they were placed in separate rooms, soundproofed, like measurement rooms, and only they could then communicate through the game.
Yeah. Thank you.
Thanks. All right. So yeah, so I was telling already quickly about the interbrain synchronization, and the way we decided to analyze is by analyzing the so-called phase synchronization. So there's a couple of ways you could, because synchronization as such basically only means like a temporal similarity of things. So it could be measured in various ways, but what we did, we measured the phase synchrony of different frequency bands of the EEG. So the frequency bands of the EEG are these which have been kind of defined in literature, and like which you have maybe heard of as brain waves, so alpha brain wave or beta brain wave, and so on. They have given these Greek letters, and as such, their power, like how strong each of these brain waves are, can be seen as indicating certain mental states. But what we have measured here is then how similar they are in time. So that's the phase synchrony. So it looks at the waves and in kind of which position they are, if they're going up or down, and then compares that changes in that shape of the wave between the two people. So if they are changing in a similar way, then we say that there's more synchronization than if they are changing in a dissimilar way. And to be technical, we use something called the circular correlation coefficient, which has then been shown in my opinion, very convincing paper by Burgess to be a quite robust measure of this interbrain synchronization, and especially phase synchronization. And what we did was that we divided then all the EEG electrodes that we were measuring into different areas, so that we could get a little bit stronger signal, because there's a lot of noise in the EEG signal. So using single electrodes is possible, but then it can be quite like you can get much better signal quality if you average together a certain amount of electrodes. And yeah, so that was our measure of EEG synchrony, and what we then how we pursued with the analysis was that we took the performance, like we calculated kind of total performance or average performance for each of these pairs who were doing the task over all the tracks. So they were playing 4 tracks, and in each track they took both of these roles, so total 8 sessions, and then we actually did the same session 2 times, so we could compare two different like how a break affects these measures. And yeah, we took the average performance of each pair, and then we found like the closest pairs which had the most similar performance to that pair, and then we swapped the pairs so that they kept the same order of completing the task and same temporal order, but we swapped them around, so we had then like this kind of false pairs which hadn't played the game together but had performed as similarly as was possible with our data set. And this was the first stage of analysis that we did to compare then these false pairs to the real pairs, and the result from that was that we could then identify in which frequency bands and which areas there could be then something interesting, something that has to do with the interaction, because anything that we would then measure from these false pairs would be something that is not relevant for the interaction, because obviously they had not played together. And what we found can be seen in figure 3 of the article, and you can see here where we found significant differences. So not everywhere, but still in a quite wide range of different frequency bands, especially in the alpha, beta, and gamma frequency bands. So if you look at the plots there, so around between let's say 7 and 40 hertz in our range, we could find differences, and then in the occipital, parietal, central, and frontal electrode sites. So based on that, we then took a closer look at those areas and those frequencies, and compared that to the performance in the task. And then we found that that the synchrony could predict the performance to a certain extent. So we found that higher mean alpha synchrony was associated with better performance in the task when measuring, like when comparing the pairs with each other. So a pair in which we could measure higher alpha synchrony was typically performing better than a pair with lower alpha synchrony. There also was a connection with the visual spatial test score in this multiple regression model, which was quite strong as well to the alpha synchrony. And additionally, we found then with this granular analysis, which I was explaining earlier, that gamma synchrony was connected within one pair to performance. So if there was at some point higher gamma synchrony, then the performance was also likely higher. And also with this granular measurement, we end up noticing, because we're using time also in the model to kind of control for that aspect, because we thought it could have an effect on synchronization, that it changes over time. So we ended up finding that in all the 3 frequency bands, the effect was such that that synchrony was becoming lower over time while people were playing the game. So in the beginning, especially in the beta band, if you look at the figure 4 in the paper, you can see it, especially in the beta band, there was like a kind of in the beginning a strong synchronization, which then started to slowly decline. But then again, we found also that the break had such an effect that after the break, the synchronization was generally higher, and this effect somehow occurred in all frequency band, but especially in the beta band. So this is something interesting, and for which I don't have a clear idea why, but there might be some results related to video gaming also that I mentioned in the discussion of the paper that could have something to do with it. But it's definitely interesting and also something to take into account if wanting to focus on increasing this kind of synchronization in some online interaction that maybe there's a certain length of a task or like an activity that is most beneficial, and then how these breaks could affect it and so on. So of course, like one reason for this study is also the idea that we could improve this kind of online interaction with increasing maybe some synchronization online and so on. So from those point of views, these time-based effects are also very interesting. So we have listed in the paper quite many different explanations that could have to do with these results that we're presenting, but what I think it especially tends to underline for me is that I think that a large part of this phenomenon of interbrain synchronization, or an important part at least, especially when it comes to cooperative performance and task performance, is likely to do with attention, because in this case, of course, there could be some like part of it could have to do with trying to predict other person's actions and intentions and such things, but also I think there probably is an important part in the like if performance is better when the synchrony is higher, then I would expect that that it has to do with attending to the task. So when you're paying more attention to the task, you're probably doing better, and it's a kind of clear and maybe not so exciting idea, but then again quite important that if you think that you're like how this kind of social cognition works, a lot of it is about also paying attention to each other and to the same things, like how we are interacting socially is a lot about like, hey, look at that, and are you looking at the same thing as me? Are we experiencing the same thing? So yeah, that's my maybe key takeaway, that maybe yeah, attending to the same thing at the same time is what is very important for this interbrain synchronization to occur. All right. Maybe I would like to open the floor for question at this point, if that's all right.
Yeah, thank you so much for explaining your work to us, and it's really interesting. And you answered kind of a few questions I had, but are you planning or maybe currently looking at maybe people with, I assume that all the participants were healthy, or did you check if the participants were all healthy?
Yeah, in this study we purposefully recruited like people who are healthy and right-handed and so on, in that way, homogeneous pool.
Yeah, so are you planning on maybe looking at people with mental health disorders, or maybe developmental disorders like autism, or people with depression, if they kind of are able to synchronize the same way? Because what I'm asking is that let's say for depression, that there's this model that people kind of feel apart from the rest of the environment and feel like they're kind of separate from the environment, from people. And it would be interesting to see if if that would also reflect in this ability of synchronization, that is kind of down-regulated or less, or if it's the same, and if that could maybe even improve the present states if they kind of have this task every day to synchronize with other people. I don't know, what you think.
Yeah, I think that's very interesting. I did have I did make a project earlier which was like a kind of game for attempting to increase this synchronization. So I think that kind of intervention would be very interesting to study with some such group of people. I think when it comes to lab studies, then our group is maybe not the right one to do that, because I think that it would make sense to do that kind of study in face-to-face situation, and whereas we are focusing really on this digital interaction. But yeah.
Yeah, I agree. Like, but it would be interesting, since I think it's kind of a more controlled environment than when people are face to face, because it kind of, I think your way of doing it, there are less factors involved. It's like kind of pure synchronization for like a task. And yeah, I think it would be really interesting to do that, because then if, like, I don't know, other sensory information is involved, it will be harder to say if just a pure being, physically in a room with more people would be enough, or if it's really the interacting together and synchronized that way, if that would make a difference. I think your model is more cleaner than maybe having people present. What do you think?
Yeah, I agree that you can control much better what is going on, or what kind of aspects affect that. And maybe a study in which having both would be, of course. Or, yeah, always it's easy to then think what we would do with like a lot of resources, but yeah, to have both, then could compare that, like how is then a group of people like who is maybe depressed or has some other reason why maybe social interaction is more difficult, how it compares then this online interaction and then face-to-face interaction, and when it comes to this synchronization, that would be pretty cool.
And also, I think your work is really interesting because a lot of people still work from home now, and it would be really important. There's such a variety of responses at some companies, and people say it's less good for collaboration, coming up with new ideas and stuff, or it's better, or people work more or less. It would be interesting to see if there is like either different mental health disorders or other characteristics of people are just better at synchronizing maybe remotely, and other people are just not. Would be a really interesting way to screen also for companies that, okay, you should come in, you can work from home type of thing. I think also for people themselves to know, like, okay, I don't perform well just remote, or I'm fine, I can, I can just work remote. Would be interesting. What do you think?
Yeah, for sure. If we could really like take make assessment of people's ability in that way. And what I personally have been thinking, and I'm quite interested in, is whether we could use this kind of measurement also to improve interfaces. So making changes, and then changes to remote working, or remote play gaming, or whatever social interface, and then try to change it in a way which then promotes this synchronization. That I think would be very interesting, but of course quite costly to make always a neuroscience experiment in each like stage of improving it.
Yeah, and my last question before, Lavina maybe wants to ask a question, or other people in the audience, please raise your hand. But did something change, like when people played online gaming together and kind of synchronized pretty well? Did they get to meet each other before and after? And did they somehow change, like were they kind of maybe friendlier, or did the interaction between those two people change, or didn't you look for it?
So in this experiment, we actually invited pairs of people who were already friends or even partners. So we, of course, one part was that it was easy to recruit pairs in this way, that they came to the lab together, because in some other experiments we have noticed that it's often then that one person cancels and then the other person comes there, and then we cannot run the experiment, which sucks. But also we wanted to have a group of people homogeneous in this way, because it made just the data analysis easier, because other experiments have shown that this closeness can have an effect. But in this case, the people were close, so they came there together and left together. But only feedback I got was just anecdotal, and I think, in my opinion, it maybe reflected more their relationship as such. So it could have probably been the same result, but I remember there were some couples who were like bickering after the game, like, why did you do this? Why did you, make us crash into the wall? And then again, there was maybe some pairs which were like kind of had this excited feeling afterwards, like someone who has maybe done sports together might have as well. So I think maybe reflecting more the dynamics of the people themselves, like their relationship.
Oh, that's interesting. And did you check if they synchronized better, the ones that were, or did it make a difference at their performance, how they were like acting as a couple? That's interesting.
Yeah, we didn't. So we just tried to keep the pool homogeneous in the way they rated their closeness to each other, and then the only analysis we made comparing the couples was based on the performance in the task and the results of the visual special intelligence test and so on. So the behavior we didn't relate to that. It's some interesting challenge, like how to compare like this kind of qualitative data and neuroscientific data. Yeah, would be cool to try to do at some point.
Yeah, thank you. Lavina, did you have a question or comment?
Hopefully that's better. Sorry about that. I did have a question, and that was probably two. One is more on, understanding that this is driving social behaviors and interactions, or possibly doing that, right, in terms of, enhancing social relationships. Question for me is, do you sort of see any ethical or sort of I don't know what's the right word, but there's things like digital nudging that kind of happens in what we use in our daily apps at the moment, and this is where we have subtle influence or subtle manipulation, for a lack of a better word, that happens. And I'm just wondering, from a collective intelligence perspective, is that something that we should start thinking about, or is that a concern at all?
You mean, like, I think, if I understand correctly, you mean like how these social media companies might be kind of manipulating us with algorithms, or is that related to your question?
Yeah. So, in terms of us being able to, from this experiment, having the synchronicity of brain activities or behaviors, this allows for room of manipulation on a much subtle scale, right? That currently exists anyway. Like for example, the adverts that we see, the kind of content that we get. So do you think that there's room for this to be misused at all?
Right. All right. Well, I'm sure that to some extent, maybe some neuroscientific measurements in then interface design or so could have like could be used in such a way, but maybe this specific analysis when it comes to interbrain synchronization between two people who are actually interacting with each other, then it's not maybe so relevant for the mass scale kind of manipulation, because for it to be useful, it has to be an interface where two people are working together, interacting together. So it may be more for people who actually know who they are interacting with and want to do it, because it would be quite costly for them such mass scale manipulation to have then always a counterpart who is trying to, yeah. So personally, I don't think that this particular measurement is so.
Great. Thank you so much for that. I probably had a follow-up question in terms of if you had a magic wand and you could pretty much, have an ultimate sort of outcome through, various sets of experiments. What would that sort of ideal outcome that you would seek for?
Yeah, that's amazing question. I think I would pursue trying to create like a very interface which produces then a lot of connection between the people who are using it. And maybe something that interests myself a lot at the moment is the effects of latency, which we didn't tackle in this experiment. So we minimized the latency by having one computer actually producing the image to both, so there was no network connection involved. But also I would imagine that especially larger latency will cause trouble with this kind of direct connection and understanding. Like we can already see in online calls that it's harder to take turns, especially with a big group of people in a discussion. So I would try to tackle that aspect, and then I would be very curious to see if it's possible to then take certain features of our behavior and predict them. So to make them actually occur before they occur, like in some neuroscience experiments, it has been shown that these kind of volitional choices can be predicted before they occur, like as a physical reaction. So maybe in somewhere we could predict a lot of things and send it over the network so that it actually occurs at the right time when it reaches the recipient. So that if I had ultimate or limitless resources, something like that, I would pursue.
Thank you so much for that.
Hi, Frank. Did you want to ask a question?
Yeah. Am I audible? Can
Yep.
you hear me?
Perfect.
Yeah.
All right. So thanks so much for the presentation, Vati. On page 9, you're writing, our study also showed that inter-individual synchronization of oscillatory brain activity over several frequency bands can occur without physical presence or direct visual or auditory information of the counterpart of the interaction. Well, I found that fascinating. This and would take probably a whole room to talk about what is actually presence. But did you differentiate between visual and auditory reception, and if so, what are the different impacts on these frequencies? Thank you.
So in the experiment there was no audio as such, but maybe this sentence could have been formulated better also in the paper, because now that I read it like this, it made me think, because what we're trying to say here is that what if we didn't have like a video link or audio link between the people. So of course there was some visual information in the form of the game itself, but yeah, does that answer the question? Or
So you just have the game and in these frequencies, and that's what you measure, and that's it. So you have no differentiation between visual stimuli or auditory stimuli towards those that are measured.
no, in this experiment, because we only had the visual stimuli in that way. But of course, as we as our results were showing, that there was a strong oscillatory, or in the not oscillatory, occipital area was some of the strongest synchronization. So that would be related, could be related easily to the visual processing, which must have played an important role. So there's a visual motor task in a sense.
Yeah. Okay, thank you. So very much looking forward to something that differentiates that. But thank you so much for this presentation. It highlights the direction that I'm also on. Thank you.
Thanks.
Hey, Eric, did you have a question? Welcome.
Yeah, hi. So I was wondering, usually in these kind of studies, it seems very exploratory and very exciting. One of the questions that my supervisor had asked in these kind of situations was, what kind of therapies can we develop from these kind of results, if any? So that's kind of my question, if there's any therapeutic benefit here. So for example, when I was doing multisensory integration with optical flow, we were looking at, hey, can we use this to help older people recalibrate their proprioception and their auditory and visual field so they can avoid falls, for example. And that was an interesting problem to think of while we were doing the thing. So if there was any sort of therapeutic, or if you have a different way of organizing the problems, or maybe there's a different kind of question you give your students, I'd be very curious to hear what that is. Thanks.
Yeah, I think what this research, as it's aiming at improving the sense of connection over digital means, then maybe most obvious one to me is then to improve then maybe like these kind of interactions between caretaker and patient in online. So improving this connection would be like could be an end result, but then I guess interbrain synchronization itself could be a therapeutic for then this kind of group of people who might have some social limitation or divergence from other groups. So but like we were discussing earlier, and I'm not sure whether there has been studies of autistic people, for example, or this spectrum patient in relation to this, but possibly it could have a therapeutic use there if yeah, but we would have to first show that this.
Oh, okay, like in a caretaker situation. Yeah, that's very interesting.
Yeah, and in general, in any situation where we could see that increasing connection between people can be beneficial, I suppose. But I think our research is generally quite basic neuroscience focused, so we don't always we don't always.
Yeah. That's why it's a difficult and interesting research question to give to the students, because then everything is forced to turn into a therapy eventually. So you end up thinking more instead of maybe a 5-10 year horizon, you think of a 70-year horizon. And then he added this additional joke, which was imagine you had $3 billion. So what could you do then? So yeah, but obviously very wild, very wild questions. Thank you.
Thank you.
Yeah, thank you so much. Did anyone? Oh, I see in the chat, Mustafa asked what the interest is itself of synchronization between two brains. When the synchronization is highlighted, what would be the use case? I think we kind of answered it a little bit, but if you want to comment to this question, Bate, please go ahead.
Yeah, of course. It's a quite wide question, of course, but maybe something interesting to think about is the social cognition itself. So what we maybe think that how it works is that we somehow, or one way of doing is that that when we are observing another person, we to some extent try to bring their mind into our mind. So we try to experience things together with them. So maybe that's why this measure is so interesting. That maybe it to some extent is very relevant for this kind of very fundamental questions of philosophical questions even. But yeah, use cases for this, at least in the digital environment, is like the ones which I have identified are the what we already talked about, like improving the interfaces, but then also, which I haven't, I think, brought up now in this session, but is these kind of also ice-breaking activities. So maybe online interaction could need more of those, that before we get down to work, when we start solving problems or working on a document, maybe we would need a gaming session or something to bring us to this somewhat synchronized state, that we are paying attention to the same thing and we are on the same wavelength, so to speak. But yeah, maybe something like that could be the use cases for this.
Yeah, I agree with you that it's, collaboration. We need to, in some way emphasize with the other person and kind of feel be in to some extent in other people's shoes, or so I agree that brain synchronization that way makes a lot of sense, because we humans have to collaborate actually quite a lot to get things done. And I think it's probably getting more and more important, and to do that also in people that are far away from each other. It would be really interesting to, like, see if people that would just perform the same task, if they have kind of similar brainwave patterns, or if that would be completely different. Like, did you have a control like that people would just I don't know, repair a bicycle or something even online, and then if is that some sort of control you had, that people had like independent tasks that are very, very similar, and would you see also similar brain synchronization, or was it just very different, how brain's activity would reflect what people were doing?
Yeah, we had only this kind of very strict control of the so-called false pairs, so those people were then doing this exact same task and just with not with each other, but of course some very early studies related to this interbrain synchronization were exploring movies, if I don't remember wrongly. So people were watching the same movies, and then they could show that that of course that the brain synchronized when they were watching the same thing, but also that the type of movie had a difference. And I have a feeling it had, in that study, they were relating it to emotional content of those movies. But I
So,
think I now got really derailed. Sorry.
oh no, it's good. Thank you. And then, did like military find this interesting, because they might have to synchronize really well to like from people that are on the field versus people that are remote. I don't know, sending drones or something. Is that are they interested in this type of research? That's one question. And then the other thing is, do you think your data will be useful for example, training then robots and drone swarms to basically synchronize their actions to perform tasks like as a swarm, basically?
The first question is really interesting and a good opportunity to bring up the concept of interpersonal synchronization. So, what maybe interbrain synchronization is somehow based on, or at least is very related to. So, like we probably know that humans like to do this, so we like to do the same thing at the same time. For example, with dancing or singing together or playing music together and so on. But especially then this can be seen in military where people march together, and that this has been thought that it's increasing then this kind of affiliation with the group. So you feel more part of a group if you do such activities together. So I haven't seen military-related research to interbrain synchronization as such, but I could imagine that there might be some interest there as well.
Oh yeah, the warfighter application would probably be one of those keywords you want to look up. But I also immediately think of like NASA applications where you have the kind of coordination and synchronization that's required in space, because space itself is very unforgiving. So unforgiving, dangerous environments seems like a killer application for this kind of synchronization.
There is another thing too. I come from this from a very different angle. And the thing is that if the military applications, you don't really need to do it there to begin with, because, and the reason is that you will likely find that if you, let's take special forces training, Marine Corps training, when they are trained to understand things to understand what they are looking at, etc., and to interpret that in the same way, you get brains to naturally, then if you understand something the same and look at the same image, so to speak, or the same view, you will likely draw similar conclusions, which is the reason why special forces soldiers, for example, can communicate with very, very little, with very small means, because they already understand each other, because they are looking at the same thing, interpreting it the same way. And that is useful. So that is likely why you get a similar thing when you look at a game. If the game is understood and the rules for the game are understood the same way. So if we take that, that can be taken a whole lot further. Anyway, I have a lot of more thoughts about this and things that I have some level of knowledge about, but I may go off piste here and go off track. But this is coming from a shared understanding, etc. You definitely get the results that I think we're talking about here, and that can be applied way wider, and it's very little used in areas outside of elite sports, and elite functions when it comes to like special forces, etc. It can be massively used in lots of other areas, but it's not, because it's not understood very well. And the advantages of it and the payoffs, because you can scale technology easily, but this is the core of scaling human interaction in an effective way. Anyway, I hope this. I came in late here, so I apologize if I've gone off the subject.
I think that's a very good input, and also good point of view. This like acting together as a unit, because that's also what the experiment is really about. Because the two people were driving the same car, so they were acting really like as one unit. And the question about the drone swarm, I guess it's related, but then it goes more to the AI side, and maybe what would be the question to ask is that probably the AI can learn from human behavior, but can it really learn from human brain data? I'm not sure. The data is so noisy. That's just as a neuroscientist, I'm always skeptical.
Yeah, I don't know. So you mean the data is too noisy for them to learn, but isn't that also something they could maybe learn from? Because, you know, AIs are currently good at performing tasks that are kind of very predictable, but if something unpredictable comes along, they're kind of really not good at reacting in a way that makes sense. Don't you think the noise, what we call noise, is keeping the system kind of also active in a way that it could also perform in a big, like in a larger range? If you only have exactly the activity you need and you blend everything else, like over simplify it, then you don't really have a range to deal with unpredictable stuff, maybe.
I think no, I think you're right, and of course also have to maybe at some point start to think about simulations, or how we could simulate then this kind of social brain processes. I'm sure someone has already done it. I just haven't seen the paper, but yeah.
Peter, did you have any? You can go into your thoughts. I think we have a few minutes if you want to add some of your thoughts.
Did you say to me?
Yeah, yeah.
But yeah, no, I have looked very much about how you can get. I haven't. I've only to limited extent had any. I I know how. What is the likelihood of getting without running the experiments, but I can probably give a whole lot of experiments that could be run where I can predict what you will find quite accurately, because the thing is that the shared understanding of things, and that is a thing that humans assume they have a shared understanding about things to a large extent. So I come from the kind of the opposite angle, I guess. And there, when you have a fundamental shared understanding, then it improves the communication, and it also gives the outcome indirectly what we're talking about here. And that is a very interesting way, because the ability for people to explore things and work together and be able to move fast together, because it's supposedly an African saying, if you want to move far, move alone. If you want to move far, if you want to move fast, move alone. If you want to move far, move with other people. But the thing here is that you can do that if you lay the foundation, which is why air people like the Marine Corps have the basic training and also do it the way they do it. It's a very crude way to do it because they don't understand what it is that they achieve, but they achieve the foundation for people to look at things in a similar way, if that makes sense. And that can be done in other areas too. Sadly, it that training is not happening at school, and it doesn't happen in businesses, and it rarely happens in other areas. But it's absolutely crucial as far as I can tell. So it's a different angle, I think, than I would say that what I'm talking about is you getting the outcomes that you have the result for here. So, and if it can be worked the other way around, I cannot say much about, but I find I I know that the way that I suggest, it's not easy, but it works. If it works the other way around, I am not as sure of. But that's interesting to observe for me.
Yeah, so what I found is interesting. So when I did PTSD studies with different groups of people, firefighters, police officers, soldiers, and regular civilians, people that had PTSD versus not had. In soldiers, compared to other groups, PTSD actually occurs relatively less. Firefighters, the percentage of PTSD is way higher than in soldiers. And I met with soldiers then, and they explained to me how the training works, at least in the US versus in firefighters and others, is that the first training is they never say I anymore. They never see themselves as an individual anymore. Whenever they address, they never address themselves. They say we. Like they always have to see themselves in the group. They always have to talk that way too. And this was really interesting because the data. Also, then I did some resilience studies and Holocaust survivors and so on data, that the highest marker for resilience or for having PTSD, one of the highest one, was the pronouns. The more people just use I or myself or something related to that they feel apart from the rest, those had the highest symptoms with PTSD. They didn't bounce back well in the resilience studies and so on. And I thought it was really interesting that just by training people how they see themselves and to see themselves
Katarina,
in a group, that was really interesting. So that's why I thought the synchronization data would be really cool to test if people with depression or PTSD would perform the same way, or if they would improve by doing the synchronization test.
there was a thing in the past. There is an expression in French called nom de guerre, i.e., name of war, that was, and that refers to that when people went out to war, they took on a name for the war, so they left their identity as a farmer or what have you behind them when they went to war. And when they left the war, if they had survived, they left the name behind them there too and went back to the name, the normal name as a farmer or whatever it might have been. So that, as far as I can tell, links into what you have found there, because what the ugliness of the war happened to another entity, and they could view that as as a separate person in a way. So you have a lot of things like that there is a lot of evidence for too. And I think that to me it sounded like that is what you found in your what you looked at. And there are lots of other things like that that are very, very interesting.
Yeah, also in Holocaust survivors, that when they talked about what happened to them in the camps and so on, people that addressed always this happened to us, we went through this, like they did this to us, they kind of had a, I'm not saying that they were healthy, but they had a regular life, you know, a job, a family, like in that kind of term, they bounced back in quite impressive ways, versus people that and the interesting thing is the level of trauma doesn't really matter. It matters more how people saw it and how people felt after. Like there was a really interesting studies with burn victims. They measured the different types of burns, and it was not related at all, the severity, with the outcome, if they would have PTSD or not. It was more other factors, that what came after, if they felt like alone and stuff like that, that were more important. So I think that's it. Your research is really interesting in the mental health type of perspective, and yeah, it would be really cool if you would reach out to collaborate maybe with people that have patience and try this out and see if there are differences and if it would make a difference in therapeutic outcomes. So yeah, thank you.
Yeah, thanks. I agree. It's very interesting thoughts that, and also hear about this group like firefighters and so. Would be very curious to also test just that kind of group compared to the like, let's say non-trained groups, a group who has learned to act as a unit, and to see if there's really some clear difference there or not. But then also with the therapeutic use, maybe if there's a difference then with this PTSD group, for example. Yeah. Nice ideas. Thank you.
Yeah, thank you so much. I know we've been going over an hour now, so if anyone has a last question or comment, please go ahead. If not, I think we'll close the room and let Wata enjoy his rest of the Friday evening, I guess, for you. Okay, so, well, thank you so much for coming here and sharing your research. This is really interesting, and I think will be really useful in a lot of different ways. So I hope you will, you get a lot of funding and collaborations to, to continue with this. Are you planning to continue after, are you planning to continue to work in this field and do more research in this direction?
In one way or another, yeah. Let's see how it turns out, but yeah, for sure. And thank you so much. It was very nice to visit here, and everyone enjoyed their weekend.
Yeah, thank you. And if you have updates or some projects you want to share with us, please feel always invited to come back. It was such a pleasure having you here, and yeah, we are curious to follow along your research and your career. So thank you so much.
All right, thank you. Bye bye.
Bye, and thanks everyone for coming and interacting and asking questions. We'll have more rooms next week again. We have Dr. Florindo. She's from cancer researcher from Lisbon. She will talk about cancer immunotherapy that she made in a very cheap way, basically, and scalable way, because usually it's really expensive and quite complicated, but she made the project to kind of find a way to do this very affordable and scalable, so that hopefully everyone in the future will have access to this cancer immunotherapy, which is a quite successful way of treating cancer. So she will talk about it on Monday at 2 p.m. And then we'll have Dr. Lazarov. He restores memories in mice with Alzheimer's disease. And then on Wednesday, we'll have model predictive organism design with biophysics and machine learning with Dr. Howard Salas. And Thursday, we'll have Venkataramani talking about glioblastoma and how this cancer type manages to invade the brain, because it's a quite severe aggressive cancer type, and they figured out how it manages to invade the brain. And on Friday, we'll have Dr. Goodyear talking about how he visualizes heartbeats in vivo with the antibody dye that he developed. It's really cool. He has like very cool videos of heartbeats and how they go along the muscle. So yeah, I hope I hear you all back soon. Thank you, Bette. Enjoy your weekend. It was such a pleasure having you. And bye, everyone. Close the room.
Thank
3.
you. Bye.
Thank you, Lavina. It was nice having you here. Thank you.
Yeah, you too. Nice seeing you again.
3, 2, 1. Bye, everyone.